like humans, applications have a life cycle. It begins with the scoping of the application, understanding what it needs to do, who it's for. It then moves on having defined the requirements into a development mode, designing the application and eventually deploying it. In the operational mode, IT teams will be concerned with security, scaling, user permissions, adding new users, general housekeeping, log files to make sure that the data is secured, is being used properly. We move on to a review process to make sure the application is doing everything it should be doing, and in some cases, new requirements for applications will be determined. But what actually are we building? In the live wireframing process, we identify different types of page constructions, and these we call application constructs. Here's a list of them. I'm just going to walk through them very quickly. The first is a start wizard. It's allowing a user to arrive at a friendly page and go through a series of things that they need to do when they arrive into a new application. The next example is a keynote, typically presented to a senior manager or executive that provides them a summary of what's happening within a process or a part of their business. In this example, you're looking at a landing page, the sort of page you would land at the first time that you open an application. And as a user within a user group, you would expect to see the features and functionality that's relevant to you and your needs of that system. The next example is a highlights panel. This type of panel allows you to see an overview of what's happening within a process and then have actions on the right-hand side to act on those processes. We see something similar here in the form of a work page. This would be the typical day-to-day activity page for somebody that's running a specific type of process. In this case, tender management, managing sales tenders and responses. It allows a user to see all of the work packets that they're responsible for and to see the progress of their activity. They can then act on any deficiencies in performance or things that need to be done by clicking on one of the buttons related to that item. It's a very logical structure, and it means that people can very quickly get to understand the system, what it needs to do, and at any point in time, they know how to prioritize their work. The next example we've got here is a data entry form. Something like 60% of the forms that get produced in an application are simply managing the data within tables, adding, modifying, removing. Those sorts of functions are typical of any type of database-centric system. And so you're always going to see these types of data entry forms. But you can simplify them by creating wizards. And even the wizards with Encanvas are created in a canvas itself. The next example is an assembly where you're actually seeing a table of records, and then below the table, you can see the detail of the record you've got highlighted. The next example is a content library, the sort of format you'd expect if you were building a records management system, a document management system, a web content management system. One of the most popular ways to look at data is through a data visualization. That could be a map or a schematic, and you can then link from those pins directly to the data records. So these forms of visualizations and maps are extremely powerful to make data come to life. Another example here are reports and dashboards, where you're able to summarize the performance of the company, of a process, of a department, by looking at that data in the form of a dashboard. Within any system, you're going to have systems tables and user tables. In this case, we're showing a user menu with the layout of the records on the left and the detail of the records on the right. Another page construct that's very popular is a share page, where you're able to look at a particular document or asset and share it with your colleagues or publish onto social media. When applications designers create their application, they have the option to create export forms. One of the concerns, of course, with exporting data is the risk of data loss. So production of these export forms is normally constrained by the systems administrator. For most applications, one would expect to have application-specific systems tables that will need to be managed by the supervisor of the system or the user themselves. When we look at this chart here, it just shows the challenge that companies face when they're doing their own in-house developments. Building an application is a creative process, and it's never guaranteed to produce 100% results. Understandably, that's a concern to project sponsors. Encanvas helps to reduce much of that risk, partly by reducing the cost of development by having fewer people required to build an application, but also in the speed of prototype development. So the stakeholders and users of a system get to see the system very quickly. That means the risk associated with the project failing is far less. Another major benefit of Encanvas is that its ability to iterate is very quick and inexpensive because all of the application detail is locked inside the canvas. For developers, it means that they can change the data structures, the report layouts, the look and feel of the application very, very quickly without having to rely on third parties. How companies have gone about building applications has changed over time. Back in the 90s, it was common to have large project teams because each of the disciplines of a development, the content management, database design, web design, all of these things required a separate specialist. That meant that building an application was a team activity often performed in the back office, because the time taken to code and develop the application meant that it wasn't sensible for a stakeholder to sit in the room while it was happening. This created a barrier between the IT team developing the application and the users and stakeholders of the business wanting to use it. Projects would require a project manager because projects were so complicated in their structure and unwieldy. The project teams would only get together once in a while. Sometimes when you brought all of these threads of a project development together, they just simply didn't connect. By 2010, software development had evolved. With new web-based development toolkits, it was possible to have fewer developers. Those developers would meet first thing in the morning and they would agree the work that they would do to deliver by the end of the day. This Scrum approach meant that agile development could take place, albeit it still required several developers to build any particular solution. Skills were still required in coding and scripting to make that happen. Now in 2020 with Encanvas and codeless development, it's possible for a single business analyst to build an application in near real time with the stakeholders in a workshop. That removes the Scrum principle because you only need one person to build the application. 60% of the application is already built in the framework of the application's platform. The term we use to describe this new development method is called live wireframing. It's about producing a prototype of a new application within a workshop environment without the need of coding or scripting. Live wireframing adopts a fail fast principle. It's better to know if something isn't going to work and correct it than to spend a lot of time building something only to find that it doesn't work. The key point about live wireframing is that it's engaging users and stakeholders who have an interest in the system and are going to have to use it. It also means, though, that the starting point for any application design is to understand who are the stakeholder groups and who are the users. It may be necessary to define and build the user group, but very often the users themselves already are identified by an organization and have an identity on the computer systems that are already being used, in which case platforms like Encanvas will harvest that user data just as they do any other form of data. It means then that users can log in to Encanvas using the same credentials they use to log into their back office systems. Everything in live wireframing happens quickly, and it does so because the first goal is to achieve a workable prototype. The scoping activity is no different to that. The method we use for scoping is called SERPs, which stands for Stakeholders, Records, Processes, Reports, and Settings. These are the 5 key areas of any application design. An important aspect of any scoping activity is to understand the data design and where is the data going to come from for the application. Sometimes it will require new data structures. Very often, those data structures may already exist in one form or another. Alternatively, it might be a blend of both, having some new structures required to blend with existing structures that are already in place. Designing a process in business can be complicated, partly because some of the processes themselves are manual, others are automated. Wherever possible, part of the decision in the scoping exercise is to understand which activities must require manual intervention. It's then a case of developing the human interfaces for the manual activities and machine-to-machine interfaces for the automated processes. An important aspect of application design is the usability of an application and how it looks and feels. It is the Encanvas architect that's ultimately responsible for the look and feel of all of the applications deployed on the application fabric. The role of the business analyst creating an application using Encanvas is to focus on the priority outcomes of what the application needs to do, the job it needs to fulfill. So now you know a little bit more about live wireframing. In the next lesson, we're going to look at how Encanvas supports the life cycle of software development using live wireframing. So that's what a canvas is. Let's investigate in the next lesson where it fits in the development life cycle.